Hi everyone, so today I will be presenting to you some examples on word problems that involves basic concepts of quantum mechanics. For the first example we have here, find the first two energy levels for an electron confined to one-dimensional box, 5 times 10 raised to negative 10 meters across, about the diameter of an atom. Now, since we are going to look for the first two energy levels, we have here our given n equal to 1 and n equal to 2. These are your first two energy levels. And then we have your length, that is 5.0 times 10 raised to negative 10 meters. The mass of your electron, that is 9.109 times 10 raised to negative 31 kilograms. And your Planck's constant, that is 6.626 times 10 raised to negative 34 joules per. Now, to look for your energy level, we have the following formula, that is E sub n equal to n squared h squared divided by 8, your mass times your length squared. So first we will solve the energy for n equal to 1. We have E sub 1 equal to 1 squared h squared over 8 ml squared, or this is just your h squared over 8 ml squared. So substituting our given values, we will have 6.626, your Planck's constant, times 10 raised to negative 34 joules per second, this squared, divided by 8 times your mass, that is 9.109 times 10 raised to negative 31 kilograms, times your length, that is 5 times 10 raised to negative 10 meter squared. So calculating this, you will be obtaining 2.4 times 10 raised to negative 19 joules, or in terms of electron volts, this is 1.5 eV. Now for n equal to 2, we have E sub 2 equal to 2 squared h squared over 8 ml squared. This is 4h squared over 8 ml squared. Substituting our given values, we have 4 times your Planck's constant, 6.66 times 10 raised to negative 34 joules per second squared, divided by 8 times our mass, that's 9.109 times 10 raised to negative 31 kilograms, and your length, that is equal to 5 times 10 raised to negative 10 meters squared. So this will give us 9.6 times 10 raised to negative 19 joules, or in terms of electron volts, this is equivalent to 6.0 eV. Now we have obtained both our energy for n equal to 1 and n equal to 2. For the second example, we have an electron is confined to a one-dimensional region in which its ground state, n equal to 1, energy is 2.00 electron volts. A, what is the length of the region? And B, what energy input is required to promote the electron to its first excited state? So to answer this problem, we will write first our given. We have our n equal to 1. Our E sub 1 is 2.00 electron volts, or this is equivalent to 3.204 times 10 raised to negative 19 joules. And the mass of our electron, that is 9.109 times 10 raised to negative 31 kilograms. This is what we are going to look for letter A, we will use the formula of E sub 1, that is h squared over 8mo squared. So transposing this equation or this formula, where L will be left on our left-hand side, L is equivalent to square root of h squared over 8m E sub 1. Now, we are going to substitute our following given to this formula. So our H is 6.626 times 10 is to negative 34 joules per second. This is squared divided by 8 times our mass, that is 9.109 times 10 raised to negative 31 kilograms, and our energy or our E sub 1, that is 3.204 times 10 raised to negative 19 joules. So don't forget, this is square root. So here, you will be obtaining the value 4.48 times 10 raised to negative 10 meters. So this is now the value for L. So for letter B, we are going to look for the energy input for the excited state of our electron. So we have delta E equal to E sub 2 minus E sub 1. So still using our formula, okay, for our E sub 2, we have N sub 2, N squared, H squared over 8, MO squared minus our N sub 1 squared, H squared over 8, MO squared. Or this is just N2 squared minus N sub 1 squared, H squared over 8, MO squared. Our N sub 2 is 2 squared minus 1 squared, right? Your H squared over 8mo squared. So this is just 2 squared, that's 4 minus 1. We will have 3 times our H, that is 6.626 times 10 raised to negative 34 joules per second squared divided by 8 times our mass, that's 9.109 times 10 is negative 31 kilograms. And our L, that is 4.48. This L is what we have obtained for letter E. 4.48 times 10 raised to negative 10 meters squared. If you calculate this, you will obtain 9.11 times 10 is negative 19 joules. Or in terms of electron volts, this is 5.70 eV. So this is now our delta E, or our answer for letter E. Those are the 2 example word problems for this topic. So if you have questions, clarifications, and suggestions, please feel free to send me a message through my Facebook Messenger. Thank you and God bless.